Oh, hey there, Internet. Well, today I'm working on my golf swing. Maybe you want to join me. We're going to talk about 2D to 3D epipolar pose estimation for the golf swing analysis. It's going to be a lot of fun. Come on in and join me.
Well, maybe you've been wondering where I've been, and obviously I haven't made a video since March of 24. Thanks for everybody for watching that video. It does seem like insane verbosity isn't completely unappreciated because I did get a bunch of views on this Tang Nano 9K video. So, with that being said, where have I been? I've been playing a lot of golf. I've been trying to get outside. I've been trying to lose a little bit of weight. And one of the things that's been happening with my golf swing is that I'm hitting the ball okay, but like the a couple things that I was having problems with. The first one is my club head speed just wasn't where I thought it needed to be. Okay. The second thing is like you can see how far ahead my hands are here, and the effect that that's having ultimately, which I figured out through a bunch of this work that I'm going to tell you about today. But the effect of this is that the club is getting delofted, and I'm basically, if this is an 8 iron, I'm going to turn it into a 7 iron by doing this. And I also can't hit a fade or a cut to save my life. So I just have this very, very, very inside out swing path and a shut club face. Okay. And I'm leaking power somewhere. And so I was watching some videos, I was doing some research, and this position where my hands are here, I think this is called P6. I think this is not great. I think I wanted to basically release the club a little bit earlier. And so I was doing some research into, where exactly should my hands be in different positions, and what is the acceleration curve as my hands are going to come down through impact. What's my acceleration curve going to look like? Now, this video from these amazing guys at Athletic Motion Golf, they do a whole bunch of motion capture and golf swing analysis, and they have probably like $100,000 3D motion capture setup. They made this great video where they show basically a pro on the right here and an amateur on the left, and they show the peak hand speeds and where they occur in the swing. And the pros, they hit their peak hand speeds in this region, this green region. And what I was doing is I was hitting my peak hand speeds in this red region. And that was causing me all sorts of different problems, very, very big problems. Because you only have about 50 milliseconds to basically from when you get to this point to when you get to impact. And unless you are starting to dump the energy into the club in this green zone, you're going to basically lose energy. You're not going to get a good transition of the kinetic flow up from the ground through the arms into the club, because basically you just don't have time to do it, number one. And number two, you can see this in the speed curve of your hands when you look at your hands as they go through and swing. So I figured out a way to do this calculation to figure out exactly what my hand speeds are in my golf swing. And so Canova has this sort of built in. You have to do a couple things to calibrate everything. So the first thing that you do here is you calibrate some line in pixels and then translate that into images. So this is the mat's 46 inches. That's the calibration for basically the same plane that my body's on. Gets you close enough. The next thing you have to do is you have to go here and click on time calibration, and this should be 120 frames per second, which is what my camera captures at. The video file is 30 frames a second, so you have to do that calibration. Once you have that done, you can basically take a marker and try to find a distinct spot on the image, and you basically click start tracking, and it will attempt to basically track that point through the swing. And you see there it actually starts to lose the positioning for that point. So I am going to crop the video at that point. So this gives us a track point in 2 dimensions, and we can go up here to Tools, Linear Kinematics, and we should be able to see exactly what that hand speed curve looks like. So ignore this this second value here, but essentially my hand speed goes up to about 10.4 meters per second. That's about 24 miles an hour. Now this is a big indicator right here that I have a problem, because the average pro hand speed peaks at about 20 miles an hour. So I am, 20% faster than that, 10%, 20% faster than that. But my club head speeds are nowhere near a pro's club head speeds. And one of the indicators of that is the deceleration. I go from 10.4 to 7.6 meters per second, which if I really had a super efficient transfer of energy, this curve would be going down to, maybe as much as 5 meters per second as I'm uncocking my wrists and dumping that energy into the club head. So I'm missing something there. The other thing you'll notice here is that is the timestamp of when this peak happens. So it's about 1675 milliseconds. So if we close this, we can't actually scroll anything while this window's open, which is one of the big annoyances I have with this whole piece of software. But once you close this, we can scroll to 1675. And you'll see right here is that I'm in the red zone. So I am in this zone right here. My hand's a little further forward into my hip because I'm going to really forward press the club. But this is not the ideal point at which I want to peak my hand speed. I actually want to do that much earlier in the swing. And that takes a conscious effort, because there's a lot of muscle memory going on, and I only have 50 milliseconds. Let's see, I'm at 1675. Let's scroll forward to impact. There's impact, and that timestamp is 1733. So that's very little time to do anything. There's very little time to transfer the energy. And so this is the thing that I discovered. But the problem is, every single time I wanted to do this analysis, I had to, manually calibrate the line, calibrate the time synchronization, place the marker. And sometimes you put these markers on there, they don't track correctly, and there's a whole bunch of problems. So I was thinking, well, there's got to be a better way to do this. And so I started digging around. I was looking at pose estimation software. I was looking at Detectron 2. I was looking at dlib. There's all these like two-dimensional computer vision algorithms, and I started to do some research. So the first thing that I did was I found some pose estimation software, and this is using Ultralytics. There's also this thing from Super Gradients called yolo-nas-pose, and what you can do is you load it up, and basically it takes these 2D images and it infers the joint positions from these 2D images. It works pretty well. You can see the confidence levels. They're very high. And then here's an example where I actually took one of my golf swings and I mapped that in there. And I thought that was actually pretty useful. And then what you can do is you can actually you can process video fairly easily. So here, this is basically a video sequence where I've taken those poses, and then I've frame by frame calculated the poses and then composed those different poses into a video file. That was my first attempt. Here's another attempt, basically the same thing, probably with a little bit different confidence levels. Here you can see, instead of doing the pose analysis, what I'm doing here is I'm actually looking at 3 different classes. Not my human skeleton, but I'm looking at my hands. I'm identifying the shaft of the club, and then I'm identifying the club head. And if I have those, then I can very easily figure out where they are in 2-dimensional space, and then figure out the accelerations and speeds and stuff. But this is my first attempt, and you can see there's a bunch of bad detections in here. So I basically had to train a model. So on RoboFlow, somebody I guess didn't have anything better to do, or got a grant or something. And you can see here that they've annotated the club shaft and the hands in about 9,000 different videos. So you can see the hands, you can see the shaft, you can see the club head, and they're all identified as different classes. And so I took that data set, I trained it, I did a bunch of iterations. You can also do tracking, but if you don't tune the parameters right, you get like a bunch of different tracks. This one, it's finding the center point of these classes. And that's the really the interesting thing, because I can calculate club head speed and I can calculate hand speed. And so that was all very interesting. I made a lot of progress with that. But in order to take a break from doing that, you can see I have some bad detections. It thinks this mouse on the floor is a hand class, I think. But anyway, I found this other thing based on some feedback from the author of this software, Canova, and she said that she was integrating in a library called Sports3D, so I went and checked that out. But then Sports3D said if you want to do 3D analysis, then there's something called pose2sim. This is pose2sim. It's on GitHub by Perf Analytics, and this is markerless pose detection along with basically using epipolar coordinates and camera calibration. It will actually translate the 2D poses into 3D poses. This is all interesting, but the main thing in order to get this work is you have to calibrate your cameras. And so there is another library called Caloscope, and this is Caloscope. So Caloscope basically, you have to generate this pattern with these little marker indicators that are like QR codes. So you create this pattern, and then you have to hold up the board, and it'll tell you what your lens distortion of your camera is, and there's a bunch of different intrinsic camera parameters that you have to calculate. And then you actually have to shoot from both cameras with the same board, and that is what's going to calibrate the extrinsic camera parameters, basically like how far away the cameras are, what the different heights are, what the rotation of the cameras are. And once you do all those different things, once you calculate all those, you can actually, in Caloscope, you can feed in video. And here's an example. It's not the best quality, but I thought this was super promising. And this is a three-dimensional model of a golf swing. So you can get behind the model, and you can see here the hand detection isn't really great, but everything else is working pretty good. So it took a pretty huge amount of effort to get this working. But once I got that working, I could feed the calibration data back into the pose2sim library. And I was able to run that on pose2sim. And I just want to open up the configuration file because there's a couple things in here that were particularly difficult to figure out. So the first one, I mean, I guess I'll just make a couple statements. So like, oh, I forgot how to use them. So like this participation height, or participant height, and the participant mass, I don't know how important those are. The one that really got me was the default configuration here uses this pose estimation configuration. I guess this is a configuration, probably also a specific model. I wasn't able to get that to work, so I had to use this particular one right here, which is called Coco 17. Once I used that, I got much more accurate detections. I had to change the key point. Basically, it picks one key point to do the tracking, and this was set up for neck, so I changed this to right wrist. That also helped the result. You may want to change some of these confidence thresholds. The really important one here was to pick convert and pick the convert from Caloscope configuration for the camera configuration. That was, you have to make sure you get that one right, assuming you're using Caloscope. There's a bunch of other calibrations that are supported. I picked Caloscope because I think it was the easiest one. And then the other big issue I had was basically this person association. So it's basically trying to track the pose and associate it with a person because it does support doing multiple people in one scene. And the critical value here was this this reprojection error threshold association, which is a value, I guess that's in pixels. This was pretty low in the default configuration, so I bumped this up, and after I bumped that up, it was able to work. So I was able to generate almost everything in here. The thing that I was not able to figure out how to finish was the final step, which is this kind of kinematics creation. And again, well, not again, but you know, this is kind of designed for this thing called pose2sim. I can't actually get that to run on my machine. There's some kind of Java error that's making it impossible for that to happen. So rather than do the, I guess what's the default, which is pose2sim, I was able to load the data into Blender. And while I can't load the model because the kinetics, or I don't even know what the issue is for that, I was able to load the model into Blender. And then you can see here, if you squint your eyes, these are my hand points right here. I'm actually able to do a fairly good 3D representation of a golf swing without the model, just the key points right now. And so that's basically as far as I've gotten. So I think the next step for this whole project is to number one, decide, do I want to use these key points here, or is it easier just to use hands, shaft, club head? And maybe I can combine those. And so, you know, one of the things I'm thinking about is you know, how, I don't know how hard it is to retrain one of these pose estimation models to add in additional things, but maybe I can run the analysis separately. So basically I can create the you know, these key points, and then I can add these in, like, you know, on top of that, and then run the epipolar 2D to 3D conversion. So I'd like to have a player that works like this, that I have this frame synchronization already working. But below this, I want to have like basically a graph that will show me different values based on the time index, right? So if I want to see what my peak hand speed is at this particular moment in the swing, it would show that. It would basically scroll a cursor along to that point in the graph, and I can see that value, and I can also see where it peaks. So I can see at what point in my swing I have the peak acceleration or the peak speed of my hands, and then that will give me some feedback for my actual golf swing. So that's where I'm taking this whole thing. It's been learning a whole bunch of different stuff about, you know, how to get AMD GPUs to work with Torch, PyTorch, and there's just been so many different things that I've had to figure out, and training models and annotating models and segmentation versus key points, and there's just so many different things. This is part one. Hopefully there's going to be a part two where I actually have a way to automate the generation of those curves kind of on demand. And once I have that automated generation, then I can very easily, after a swing, I can click a button, generate it, look at it in a way that's intuitive and gives me the data, and then make adjustments and basically improve my golf swing. So anyway, machine learning, computer vision, 2D to 3D, epipolar coordinate translations. It's been a lot to learn. If you have any questions, if you have any comments, leave them down below. If you play golf, go play golf. Don't watch my videos. Thanks for watching, and I'll see you next time.